Hey everyone, this is Kawaljeet Kurmi working as Principal AI/ML Specialist Solutions Architect. In this session, we will discuss one of the recommended best practices to prepare a large dataset to pre-train a generative AI foundation model using Amazon SageMaker. So with that, let us get started. So let us drive this discussion with a use case. And the requirements are we want to create a framework which could process a data set which is in gigabytes or terabytes in size. We want to save the processed data in a persistent storage for further analysis. And we want to pre-train a model from scratch. And we'll take Falcon as an example and pass this processed data to this training cluster through a high-performance file system. And what we need from this solution? We need a managed experience where we could quickly spin up a development environment for data processing and analysis. We need the flexibility in the choice of compute and machine learning frameworks or libraries. And we need a high performance system which could be optimized for cost. So let us take a step-by-step approach to this solution. In step one, we will spin up a SageMaker Studio Jupyter Lab notebook environment. You can use this environment to analyze and process a smaller data set. However, when you are working with a larger data set, that's when you want to process that at scale, right? And we will be using SageMaker job parallelism here. Now, using this concept, you can spin up multiple SageMaker jobs, each job running one or more instances, and we'll use FSX for Lustre file system as a file system attached to these nodes. Now, FSX for Lustre is a managed shared storage which offers the scalability and performance of the popular Lustre file system, and it provides hundreds of gigabytes per second of throughput and millions of IOPS, exactly what we need in this use case. We will use Hugging Face dataset C4, which is a common crawl corpus dataset created by Allen AI. This dataset is clean, deduplicated, and is commonly used to process large language model. Now, Hugging Face C4 shards its dataset into multiple different files, and we will process those files in batches with these SageMaker job that we have spun up. And every job will be processing its own batch of data. And once they are done with processing, each job will save those batches as a data set in the arrow format. Now, FSX for Lustre could be linked with S3 as well. S3 is a simple storage service, and we could link FSX using data access repositories. And once you do that, any changes that you make to the FSX for Lustre file system will automatically be synced up with S3. And then we will mount the same FSX for Lustre, which is already pre-warmed with our processed data, to the training cluster, where every node in that cluster will have access to that mounted local folder. And the data set that we have processed, we will concatenate that together into one big data set, and we'll use PyTorch FSTP libraries to run our training in a distributed fashion. So with that, let us see this demo in action. Okay, let's look at the Hugging Face dataset first, right? So this is the Allen AI C4 dataset, and if you see, we have 1,024 shards. So there are 1,024 files that we could process in batches. Now, our next step is let's create and see an FSX for Lustre file system. So I go to AWS console, and you can go to FSX for Lustre using this search bar. We have already created a file system. Let's quickly look at the key parameters in that file system. So once you create the FSX for Lustre file system, this will create a unique ID, which will uniquely identify this file system. It will also create a mount name, which you will use to mount this file system to an EC2 node or to the SageMaker training cluster. You can define your storage capacity when you create it, and you can change that later, and same applies to throughput. And there is a network configuration that you will specify when you create this file system, the VPC and subnet. A quick tip here, make sure that your FSX file system is created in the same subnet where you will be running your SageMaker training cluster, so that they can stay close to each other, giving you the lowest latency in your training run. One other thing is the data repository that we have talked about. Here we have created a data repository and mapped a file system path /C4 to an S3 location, right? We'll use this path to access the data that we have processed in our training cluster. So with that, we will now quickly look at the SageMaker Studio, and we'll spin up our Jupyter Lab application to start data processing. Now, SageMaker Studio is a web-based IDE environment which provides purpose-built tools for data preparation, model building, training, deployment, and many more. We'll be using the Jupyter Lab application of SageMaker Studio. So you click on this link, and this will take you to this page where you can create multiple different Jupyter Lab spaces. Every space is private to your studio environment, and it manages the compute and storage resources for you. And we will click on this open link, and this will spin up a Jupyter lab. Okay, so we are on the Jupyter lab notebook here, and we're going to run this. So to start with, we will be importing certain dependencies that we will need to run this Jupyter notebook. We'll be working with SageMaker Python SDK. Now, this is a high-level abstraction which helps you interact with SageMaker. And one of the key components of that SDK is SageMaker Session right here. SageMaker Session allows you to interact with SageMaker APIs in a very abstract way. And as we have discussed, we will be using Falcon 7B model in this example. This is a model created by Technology Innovation Institute, one of the very popular models of this time. So the step one is we will use a utility function where we will feed in as parameters the number of split files, which is 1024 as we have seen. And we have decided randomly in this demo, there will be 15 workers that will be working on those split files in parallel. Now this function will create a list of 15 batches where every batch is of size 68. So we will be spinning up 15 SageMaker jobs. We'll be mounting FSX for Lustre to each one of those, and each job will be processing a batch of 68 files in parallel. And the way you will configure FSX for Lustre in this case is you will use file system input API here. This is the API which will allow you to use FSX as a data source for SageMaker training runs. And you would need the mount name and the file system path that we have connected to S3. And you would need the unique ID that will identify what file system you'll be working with, right? And then you will create a data channel which you will pass on to the SageMaker training cluster. Okay, now before we spin up 15 different jobs, we will just try out with one job and we'll see if it runs successfully, right? So there is a for loop here, and we have intentionally running it for one job, and we'll be passing on 68 split files for that job to process. Few key things here. We will first create the hyperparameters. Here we are specifying the number of processes that we want to run in parallel to work on data processing. Now we'll be using M524X large instance, which comes with 96 vCPUs. And we are just defining that we want a thread for every CPU. We'll pass on the split range, which is 68 in this case, and the job name that will help us identify the specific job and browse the FSX later on after the job is completed. Okay, now after that, we have the PyTorch estimator. Now this is an API which does a couple of things for you. First thing is it helps you spin up a training cluster as specified in the configuration. So we are saying that we want one instance to be spun up which is of type M524X large. SageMaker will handle the setup and management of this cluster, which brings down your total cost of ownership. And secondly, this will also provide you with the pre-built containers managed by SageMaker, which you can specify using the framework version and Python version. Now these containers are optimized. They have the compiled version of PyTorch framework and the related dependencies. It has CPU libraries, GPU libraries, CUDA stack, the network stack, which allows different nodes in your cluster to communicate with each other. So if you see, there are a lot of libraries that kind of plays out when you run a multi-node training, and you don't have to worry about that. SageMaker already handles that in the pre-built containers, and you can focus on your code, right? And you can pass on that code to these training clusters as an entry point right here, right? So data.python file is the one that I have already created, and I'm passing on to this training so that our cluster can process that. Before we go further, let's quickly look at this data.python file. A few key things in this file. We will use the create batch function, which will create the batches of the actual file names. We will download the dataset using Hugging Face load dataset API right here. We will pass on that split range, the list of files that we want to download. And this is a multi-process environment, so we will mention how many processes we want to spin up to do this activity, and the cache directory where we want to save our dataset and cache it. Now, a quick note here, make sure that your cache directory is mentioned in the file system, FSX file system, and not the local directory in your compute instance. And then we will pre-process the dataset. We will use Hugging Face tokenizer to tokenize our data using dataset.map function. And once the dataset is tokenized, we want to use a particular function in the partial mode to map that tokens to a specific sequence length. So we are using 2048 as the batch size here, which will be handled by this group text function. So with that, we'll quickly move back to our notebook. So once you have defined this estimator, you will call the fit function to spin up your training cluster, right? We have kept a wait flag here to set to true, which means we will wait for that execution to end, and all the output that your container will emit will be emitted here, right down the cell. Okay, so if we look at the output, we'll see that we are downloading the data, we are generating train split, we are running the tokenizer on the dataset to create tokens, and finally we will map the dataset to the groups of 2048 sequence length and save the dataset to the FSX Lustre file system. So once we have seen that our single job is running successfully, then we will run a for loop to spin up 15 different jobs that can work on their own batches in parallel. Okay, so we'll use the same for loop. We'll call estimator.fit function, and every single function call will spin up one job. And we are passing a flag wait is equal to false here, which will not wait for the cluster to complete the run. And this will happen in the background, and you can track the execution of all of these SageMaker jobs either through SageMaker console or through SageMaker Studio Web IDE interface. Okay, now once the dataset is prepared and saved to the FSX file system, then you can browse the dataset in one way, where you can create a smaller EC2 instance and you can mount FSX on that instance, and then you can SSH to that instance to see if the dataset created is in the right format and the directory structure is something that you expect. Cool. So once we have prepared dataset, now we are in the second step where we'll be pre-training Falcon 7B model, right? And similarly, what we did in the previous case, we will create our hyperparameters first, where we will pass on all the variables that our training script would need, like model ID, gradient checkpointing if you need that, the FSTP wrap policy, the maximum number of steps that you want to run, and then pass on that hyperparameter to the PyTorch estimator, right? And here we have specified that we want to spin up a cluster of 2 P4D 24x large instances. Okay. So here FSX for Lustre will be mounted to each of these training nodes as well, which we will pass on as a data channel to our estimator fit function. And here we kept a wait flag to true just to see what kind of output this training cluster will generate, right? And this is a training where you can track the progress of those 25 steps. And once the training is completed, your artifacts will be saved into S3 as well as in FSX. And then your billable time is the time when your training is actually running. As soon as the training completes, SageMaker will terminate that FML cluster, and you don't have to pay beyond what you have used. Now, quickly looking at this train.python file that we have used here, right? Now, the key things that I would like to highlight in this file. First, we have prepared our data set by concatenating all the data sets that each of the SageMaker job have created. And we will use this Falcon configuration, which will be training from scratch. And we are pulling in this configuration from Hugging Face repository using the Hugging Face APIs. And we will download the tokenizer to tokenize our data set. And we will wrap our model in the FSTP wrapper, and we'll pass on all the parameters which will define the behavior of how you want to shard your model, right? For example, here we are passing the auto wrap policy, which will consider this particular class for sharding the model parameters, gradients, and optimize the states. And finally, once you have wrapped the model in FSTP, you will be running your training loop. We'll be passing the batches of data to your model. You'll compute the loss, and we'll run the backward pass, which will compute the gradients. And finally, you will use optimizer.step to update your parameters. So this concludes the demo. So we have seen with SageMaker, you get the flexibility in bringing in and working with the choice of machine learning frameworks and libraries. And you get a managed experience with pay-as-you-go pricing. So you bring down your total cost of ownership by offloading the complex tasks like workload orchestration and management of underlying compute to SageMaker. Now, this managed cluster is resilient. SageMaker will ensure that if there is a bad node, which could be because of GPU failures or hardware failures, SageMaker will replace that with a good node. And then if you are using a managed container, as we have seen in this example, those are optimized for networking and compute. And if you're using FSx for Lustre as a high performance file system, you make the entire end-to-end system highly performant. And because you're paying only for the amount that you're using these resources and for the time that a training is actually running, we are optimizing this entire system for cost. So this concludes our demo. These are the resources that you can refer to dive deeper into the examples that we have seen and to the documentation. We will deep dive further into pre-training large language models in the upcoming videos in the series. I hope you have liked this session. Thank you so much.